Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I'm going to walk you through the quiz review problems for Chapter 4, Sections 4.1 through 4.4 with some additional volume problems. And as always, my disclaimer on these videos, please do not come and watch these videos and just copy down the answers. I'd like for you to work the problems first and then come back to the video and check your answers to clear up any mistakes or misunderstandings that you may have. So keeping with the tradition of starting off with the coolest college in the United States of America, best football team, we have the Clemson Tigers, who have just pummeled Miami to the tune of 38-3 to win their third straight ACC championship. And in the same time, I know a lot of you guys are Georgia fans. I'm very happy for Georgia. They just got their revenge against Auburn and won the SEC championship for the first time in a while. So Clemson and Georgia are both in the college football playoff together. So students who might be watching this video years from now, this is 2017, might remember this time frame when Clemson and Georgia have the potential, if they both win their semifinal games, to meet in the national championship game. And if that happens and Georgia wins that game, I have promised all my students that I will call in sick for about a month. Yeah, so I'll never hear the end of that one. But we'll see. Maybe Georgia and Clemson can meet and give us an instant classic. All right, so let's go ahead and jump on into the quiz review. First several problems are about the midsegment of a triangle. And our theorem says that the midsegment is parallel to the base and it is 1/2 of the length of the base. A couple of logistical things here real quick. The printer didn't catch a couple of things. Look down here at number 5. This AD, that looks like a minus sign. That's an equal sign. I don't know what happened with the printer there, so you can put a little equal sign there. And then also number 6 down here, that looks like an MC. The printer just cut it off. That's an MO. Just don't want you guys to get confused. All right, number 1 says, what are 3 pairs of parallel segments in triangle ABC? Zoom out here. All right, so here's our triangle, the 3 pairs of parallel segments. Well, if I'm looking at this midsegment, XZ, that is going to be parallel to AC. Okay, those two guys would be parallel. So we've got XZ is parallel to AC. We also have these lines. I've got YZ. That's going to be parallel with AB. So Y, and it doesn't matter the order of the letters, YZ parallel to AB or BA, that doesn't matter. And then of course the third one, I've got XY, and that's going to be parallel to BC. Okay, so that's pretty easy. All right, so the next question says, if the length of XZ is known, so if you give me this number, if you tell me this length, whatever it is, let's say they give it to us as 5. It says, what other segment can you assign a length? Well, it's the matching parallel line, right? So if the midsegment is 5, then I know that AC, that associated parallel line, is going to be double that. So in this case, it would be 10. But the question is just saying, what other segment can you assign a length? And the answer to that is AC. I would know what the length of AC would be if you give me the XY midsegment. Number 3 says, if it is given that AX is 3.5, okay, so this guy up here, AX, if that guy is 3.5, what is the length of YZ? All right, well, there's a tick here, right? So we've got ticks everywhere to let us know that these are mid segments. So if this guy is 3.5, that means what is this other piece? This other piece is also 3.5, right? Okay, so the whole length AB, this whole guy, if I add those together, 3.5 times 2, that whole length is 7. Okay, so then it says, what is the length of YZ? Well, YZ is half the length of the whole base, right? In other words, another way to think about it is I can take 2 of these 3.5s, put them together, that's the whole length. So the midsegment is just going to be one of these guys because the midsegment is half of this whole thing. So it's basically just one of these guys. Or, yes, the midsegment is half the base, so I just take 7 and divide by 2, and I get 3.5. Okay, two of these guys is the whole base, and one of these guys is just half of the base. That's another way to think about it. All right, number 4, if BE equals 2x plus 6, and DF is 5x plus 9, find the length of DF. Okay, BE, what is that guy? That's this guy right here. All right, is that a midsegment or a base? That's a midsegment. I've got the double ticks here, the double ticks here, single tick, and single tick. So that's definitely a midsegment. That's 2x plus 6. DF, the whole thing, is 5x plus 9. All right, so here's how you do these problems. All you have to do is double the midsegment and set it equal to the base. So I'm going to double this expression. So I'm going to come out here to the side. I'm going to say I got to use the distributive property. I'm going to double that whole expression, 2 times 2x plus 6, because it takes 2 of these midsegments to equal the whole length up here, right? Just like it takes 2 of these 3.5s to make up the whole 7 up here. And I'm simply going to set that equal to the base, 5x plus 9. Okay, so again, you got to use the distributive property. 4x plus 12 is equal to 5x plus 9. I want a positive variable, so I'm going to subtract 4x. So that leaves me with a positive x on the right-hand side. 12 equals x plus 9. Let's subtract 9 from both sides, and I get x is equal to 3. Okay, now that's not what they asked for. Okay, they asked for the length of DF. So I've got to take this 3 and I've got to plug it back in for x here. So I'm going to plug in a 3 right there. 5 times 3 is 15. 15 plus 9 is 24. So DF is actually equal to a length of 24. Okay. All right, I'm going to do the exact same thing for number 5, but in number 5 they're saying that EC, now they're saying this midsegment is, again, that's an equal sign. EC is 3x minus 1, and AD, this base is 5x plus 7. So I'm going to do the same thing. I'm going to double that expression. I'm going to double the midsegment, 2 times 3x minus 1, and I'm going to set it equal to the base, 5x plus 7. Distributive property, I have 6x minus 1 equals 5x plus 7. Let's subtract 5x from both sides. There's cancel. So I have x minus 1 equals 7. Add 1. X is equal to 8. Okay. So once I get, oh, I'm sorry. That's a 2. Excuse me. 2 times negative 1 is negative 2. Excuse me. Yeah, got to make sure you remember to use the distributive property there. All right, so then I'm going to add 2 to both sides. And so x is actually equal to 9. Excuse me. All right, so now x is 9. So once again, I'm going to plug it in right here to find the length of, is it asking for AD or is it asking for EC? In this case, it's actually asking for EC. So in this case, I need to plug it in right here because I'm trying to find the length of EC. So you got to pay attention to whether or not they're asking you to plug it into the midsegment or the base. This time they want us to plug it in and actually find the midsegment. So if I plug in 9 here, 3 times 9 is 27, minus 1 is 26. So EC is actually going to be equal to 26. Okay, let's move on. Number 6 says in triangle MON, J, K, and L are midpoints. Okay, so that's a midpoint, that's a midpoint, that's a midpoint. So I can put ticks on here if I'd like. So we have 3 different midsegments. And this says if JL is 11, let's go ahead and label these. JL is 11, LK is 13, and ON, this whole length down here, is 20. Okay. This is JL is parallel to MJ, LK is parallel to MO, and JK is parallel to ON. What are the lengths of MN? Okay, so they want this whole length here. All right, so that whole length is going to match up. It's going to be associated with the JL. If JL is 11, the midsegment is double that. So we'll just multiply times 2. So MN is going to be 22. Then it asks for the length of MO. Okay, so MO is this whole base. That's going to be associated with LK, which is the midsegment. Midsegment is 13, so I'll double that. So MO is going to be 26. All right, and then the last one it asks for JK. Now JK is a midsegment. And so they give me the whole base here, ON. So if the whole base is 20, I just divide by 2. And JK, that midsegment will be 10. All right, let's move on. Number 7, this is our perpendicular bisector theorem that says that anywhere on the, I know it's a perpendicular bisector because I have 2 things. I have a box and I have the ticks. All right, got to remember that. Perpendicular bisector, got to have a right angle, got to have the line bisected some ticks or some links. And our perpendicular bisector theorem says anywhere on this perpendicular bisector, is going to be equidistant from the endpoints of the line segment. We're forming isosceles triangles everywhere along this perpendicular bisector. So that means that these two lengths, RS and RU, again, that's an isosceles triangle. So those two lengths are going to be the same. I could put quadruple ticks on those two lengths. All right, so I'm simply going to set these two expressions equal to each other. 8x equals 6x plus 5. Subtract 6x from both sides. 2x equals 5, divide by 2, and x equals 2.5. Okay, but that's not what they want. They want RU. So I've got to take this. Now, do I have to plug it back into RS, or do I have to plug it back into RU? The answer is it doesn't matter, because both of these lengths are the exact same. If I were to plug it back into RS, that length is going to be the same thing as RU. So make your life easy. I'm going to choose to plug it into the easier one. So I'm just going to say 8 times 2.5, and that length comes out to be 20. So RU, excuse me, can't see that. So RU has a length of 20, RS has a length of 20. Take a couple extra seconds and also plug it into the other one. 6 times 2.5 is 15. 15 plus 5 is also 20. Okay, so that's just a great way to check your work, just to make sure you didn't make a mathematical careless mistake. Number 8 says in the diagram above, if RT is extended. Okay, so I'm going to redraw the triangle above. We have something like this. We have S, R, and U. And it says if RT, and we got T right here, it says if RT is extended. Okay, so that means if I come down here and I extend this out, and it contains a point W, call that W, so that WU, okay, so here's our new length, WU, that guy has a length of 8. What would be the length of SW? So what would be this new length here? Well, once again, anywhere on this perpendicular bisector is going to be equidistant from the endpoints of the line. So I can put double ticks on that line, double ticks on that line. So if UW has a length of 8, then SW is also going to have a length of 8. Okay, looks like I formed a kite there. Okay, let's flip on over to the back. Number 9, this is our Spider-Man theorem, angle bisector. I know it's an angle bisector because I have those two little arcs right there in the angle. I'll blow this up a little bit. And our angle bisector theorem says anywhere on this angle bisector, as long as I'm forming 90-degree angles, those lines will always be the same. So these two lines, double tick, okay? So that means that these two expressions are going to be the same. So I simply set these two expressions equal to each other and solve. 2x minus 5 equals 1. Add 5. 2x equals 6. X equals 3. So once again, you got to pay attention to what did your boss ask you to do. In the real world, your boss is going to ask you to do certain things. In mathematical classes and problems, you're asked to find links and X's and Y's. In the real world, your boss is going to say, go do this. And even if you do it correctly and it's good work, if it's not what your boss asked you to do, that's going to be an issue. Your boss asked you to find the length of CD, not X. So once again, I got to take this and plug it back in. Doesn't matter which one you plug it into, they're the same. 4 times 3 is 12. 12 plus 1 is 13. So CD has a length of 13. Plug it into the other one. 6 times 3 is 18. 18 minus 5 is 13 as well. So just double check your work. Alright, number 10. A landscaper wants to build a goldfish pond that is equidistant from the gazebo, the rose garden, and the bench. How should the landscaper determine where to build the goldfish pond? Okay, so let's go ahead and draw our triangle, and I love these types of problems because you guys know I'm real big on the real world application. Where could you possibly ever use these concepts in real life? Well, this is a great example. I want to stick a goldfish pond right in the middle. Okay, so basically this is like the problem we did in class with the spaceship chute and the roller coaster. We were trying to put a t-shirt stand that's the same distance away, and we simply said I just need to draw two perpendicular bisectors and see where they intersect. Of course, I'm doing this by hand here, so this won't be 100% accurate. But if I were to construct, I could do this with a compass, and I'll teach you guys how to do this second semester. But if I were to I'm just eyeballing this here, right angle, tick, tick. There's one perpendicular bisector. And if I do it over here, perpendicular bisector over here might look something like this, double tick, double tick. So there are two perpendicular bisectors, and where they intersect, that spot right there is going to be the spot where it's going to be equidistant from all three of my locations. Okay, perpendicular bisectors. This would be the circumcenter, where the perpendicular bisectors intersect the same distance away from the three corners of my triangle. So this is the cell phone tower. I use that in the example. You'll put your cell phone tower in the middle of three populated areas so all your customers get maximum coverage and service. Okay. All right, so I'll go ahead and write this down. Circumcenter, draw two perpendicular bisectors. And see where they intersect. Okay. All right, so next one, number 11, is AC. Is this guy a median, an altitude, or neither? And some students had questions about this in class, and they were saying it's neither. But this actually is an altitude. AC is an altitude, because remember, an altitude, all an altitude is a line that starts from the vertex and goes to the opposite side, forming a 90-degree angle. It doesn't matter that, in this case, that line is the side of the triangle. If you have a right triangle, then you basically have two altitudes. That's an altitude. If I turn my paper this way, this is also an altitude. It just needs to start from a corner and make a 90-degree angle with the opposite side. That's what an altitude is. All right, what about BD? BD is this guy here. Okay, BD is a median. How do I know it's a median? Because it starts from the corner and it goes to the midpoint of the opposite side. I know that because I have ticks right there. Now, a lot of students get this confused with the perpendicular bisector because they see the ticks. But remember, there's no 90-degree angle right here at D. Okay, so if I don't have a 90-degree angle, then it's not going to be an altitude, it's not going to be a perpendicular bisector. The only thing it can be is a median if I have those ticks. All right. The question doesn't ask this, but what if I ask that? What if I added those? What else would what else would BD be? That would be an angle bisector because I have the arcs right there. Okay. All right, so let's move on. Here is our centroid, where all the medians intersect. I know they're medians because I see the ticks here. I don't have any altitudes or perpendicular bisectors because I don't see any boxes. I don't see any 90-degree angles anywhere. All right, all I see are medians. And the centroid is the balancing spot, the center of gravity. And our mathematical relationship is that the long piece of the median is double the short piece. Or another way to think about it, the short piece is 1/3 of the whole piece. All right. So in this case, they gave us AC. Okay. Now, did they give us the long piece, the short piece, or the whole piece? Okay, that's the short piece. AC is obviously shorter than AZ. All right. So if this guy is 6.3, the long piece is just double that. Okay. So AZ is just 2 times 6.3, okay, and that's going to be equal to 12.6. All right, so AZ, this guy, maybe I can do this in this random purple and orange color. So this guy is going to be 12.6, okay. And once again, the short piece is half of the long piece is double the short piece. But then what did they ask for? Okay, they asked for the length of AZ. Okay, so we just answered that. And then they asked for the length of CZ. They want the whole thing. Okay, so I'm just going to add these beautiful purple and orange colors together. 6.3, so CZ is equal to 6.3 plus 12.6, and that gives me 18.9. Okay. So just remember, short piece is half of the whole piece. Let's do another one, even though we're not asking for this here. Let's say they give me XB. Let's say they give me the whole piece. And let's say that's 21. All right. And let's say they ask for AB and AX. If the whole piece is 21, I just divide that by 3. So that means the short piece is 7. AB would be 7, and then the long piece would be double that. So XA would be double 7, which is 14, because 7 plus 14 gets me back to my 21. Okay, so that might be the other type of problem they may ask you. If they give you long piece or short piece, and you just multiply by 2 or divide by 2. If they come right out the gate and give you the whole piece, you just divide by 3 to get the little short piece, and then you can double it from there. Okay, number 13, identify each of the following. Perpendicular bisector. Which one of these guys, let me back up here, zoom out. Which one of these guys is a perpendicular bisector? I have to have a box, and I have to have a set of ticks. Okay, well, I see a box here, but I don't see any ticks on CB, I don't see any ticks on BG. So that can't be, AB cannot be a perpendicular bisector. I've got no numbers, no ticks. I have these two lines. I've got this line that starts from the vertex and goes to that spot. Then I have this line that's just kind of a random line out here. I do have a box and I do have a set of ticks. Now, which one of these guys is the perpendicular bisector? Remember, the perpendicular bisector is the only one of the three that does not have to start from the corner. Altitude has to start from the corner. Median has to start from the corner. Angle bisector has to start from the corner. The perpendicular bisector does not. So this is my perpendicular bisector, this line right here. It's forming a 90-degree angle right there, and I have the ticks. So the perpendicular bisector is GF. Angle bisector, I'm just looking for the arcs. Okay, I got arcs there. So CD is my angle bisector. And then median, I'm looking for a line that starts from the corner of the triangle and goes to the midpoint of the opposite side. That's going to be this guy here. EF is going to start from E and is going to go to F, splitting that in half. All right, so that's EF for the median. And then the last one, altitude, starts from the corner and then simply goes to the opposite side, forming a box, forming a 90-degree angle. So AB is going to be my altitude. So let me recap that one more time. Perpendicular bisector, you must see two things. You must see the box and the set of ticks. Right, box and ticks. Altitude, you're seeing just a box, just a 90-degree angle. Median, you're seeing just the ticks. So the perpendicular bisector is the combination of the altitude and the median. I got the box and the set of ticks. Angle bisector, you're just looking for the arcs on the angle. Okay, home stretch here, volume. All right, so the first one here, we were talking about Cavalieri's principle, and so I did a little demonstration in class with Cavalieri's principle. Excuse me. It says, when working with volume, what does Cavalieri's principle tell us? And I'm telling you right here to Google it. If you can't remember, just look it up. Anytime in math you don't know something, you don't have to have your book in front of you. You guys have cell phones. The cell phone is your umbilical cord, right? Can't live without it. So just Google it. Type in Cavalieri's principle. But basically what Cavalieri's principle tells us is if you have two figures with the same height and the same cross-sectional area at every different level, then they have the same volume. So in other words, in layman's terms, what that means is if I have a cylinder that's got a certain height and a certain radius, a certain base, and I have that same cylinder with the same base and the same height, if those two are the same, if the two radiuses, if the two radii are the same and both of the heights are the same, then the volumes are equal. Okay, so all you have to really remember about Cavalieri's principle is if you have a slanted figure, then the volume doesn't change. As long as the height and the base, the radius, and the width, and all, as long as the other dimensions don't change, the volume doesn't change. It stays the same. Okay, that's Cavalieri's principle. All right, 15, sphere. The volume of a sphere is 4/3 times pi r cubed. Make sure you pay attention to what they're asking you for. Are they asking you to leave it in terms of pi, or they want you to round? If they say leave it in terms of pi, you don't type in pi, but they don't say that here. So yes, I'm just going to simply multiply all these numbers out. 4/3 times pi. Don't type in 3.14 in your calculator, please. Please type in the pi button. You get a more accurate answer. The radius here is 9. Also, please, 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 I'm begging you to pay attention to whether or not they give you the diameter or the radius, okay, because that will obviously change your numbers. They did give me the radius here, so it's going to be 9 And remember, the volume formula for sphere has a cubed. The other ones have r squared. This one's r cubed. So make sure when you type this into your calculator, you type in 4 divided by 3. I'll show you right here just in case. So let's see how we're typing this in. I'll just press 4 divided by 3 times second pi times 9 raised to the third power. Okay, I get 3053.6. 3053.6, and my units are always cubed, so that's going to be centimeters cubed on the units. Okay, that's the sphere. All right, second one is a composite figure. We basically just have a cylinder sitting on top of a box. So let's first go ahead and calculate the volume of the cylinder. And the volume of a cylinder is simply pi r squared h. It's basically, the pi r squared is just a circle, that's area, and then we're multiplying by the third dimension, which is the height. Now, do they give me radius or diameter? They give me radius, so that's good. Do they ask me to leave it in terms of pi? No, they didn't. They say round, so let's go ahead and type in everything we got. Pi times the radius, which is 4. I'm going to square that, radius squared, times the height for the cylinder, which is 8. Type that into my calculator. Second, pi times 4 squared times 8. I get 402.1. That's going to be feet cubed for the cylinder. And now we find the volume of the box. That's easy. That's just length times width times height. Volume of the rectangular prism, length times width times height. And it doesn't matter the order of the numbers. I just simply multiply those three numbers together, and that comes out to be 1344 feet cubed. Now it's a composite figure, so if I want the volume of the total, then I just add those two numbers together. So I'll say volume of the total is equal to the 402 for the cylinder plus the 1344 for the box, and that comes out to be 1746.1 feet cubed. All right, next one is a cone. Now this one, you gotta look, gotta pay attention. They ask you to leave it in terms of pi. That means you do not type in pi into your calculator. You will simply have the little pi symbol in your final answer. So volume is equal to 1/3 pi r squared h. Okay, so it's the same thing as a cylinder. It's pi r squared h. It's just a third. Okay, the two shapes that we learned about that go to a point, the pyramid and the cone, they both have a 1/3 in the front of the formula. Now, do they give me radius or diameter? Okay, this time they gave me diameter. All right, so I got to divide that by 2. 3.5 divided by 2 is actually 1.75 for the radius. All right, radius equals 1.75. And now I just plug into my equation. 1/3. I'm going to put pi, but I'm not going to type it in my calculator. The radius is 1.75. I got to square that because it's r squared. And then times my height, which is the 4 inches. Okay, so watch how I punch this in. 1 divided by 3, do not type in pi, times 1.75 squared times 4, and I get 4.08. That rounds to 4.1. But my answer is in terms of pi, so I have to put this little pi symbol right there. 4.1 pi inches cubed. Okay. And the last one here with the slant height on the pyramid, calculate the volume of the pyramid. This is actually a square pyramid. I meant to write that in there. The base is a square. That means if this length is 28, then this length over here is also 28. All right, and it says given the slant height. All right, so when you're given the slant height, this is the hard version. What you got to do is you got to come out here to the side and draw yourself a separate right triangle. Let's come out here and draw it over here. And we get to use Pythagorean theorem. Okay, so there's a right triangle. My slant height, this 50 inches, that is the hypotenuse of my right triangle. And this is the part students forget. The base, that everybody wants to put a 28 right there. But notice this base is only half the length of the full base. So I got to divide that number by 2. Okay, so the base of this triangle is actually only 14. And now the height, this is what I want. I need this vertical height down to the bottom of the pyramid. So this is the height I'm trying to find. All right, Pythagorean theorem says a squared plus plus b squared equals c squared. That just means this leg squared plus that leg squared equals the hypotenuse squared. So I have h squared plus this leg squared. And it doesn't matter which one you let be a or b. It doesn't matter where I add 3 plus 2 or 2 plus 3. And then that's going to be equal to the hypotenuse squared, which is 50 squared. So again, h squared plus 196 equals 2500. Let's subtract 196 from both sides. H squared is equal to 2304. Nobody cares what h squared is. I want h. So I got to take the square root of both sides. And the height that we want comes out to be 48 inches in this case. So now this guy's 48. Now the problem becomes a lot easier. Now I just plug it into my volume formula, which is 1/3 times length times width times height. It's basically just a box, length times width times height, but I'm dividing by 3, or I'm multiplying by 1/3. Alright, so it's 1/3 times the length, 28, times the width, another 28, times the height, which we just calculated, 48, and that volume comes out to be 12,544 inches cubed. Okay, the second part of the question said, how would this problem be different if you're given the regular height instead of the slant height? So let's say they didn't give us this. If they just come right out of the gate and give me that height, then the answer to that part of the question is quite easy. I don't need Pythagorean theorem. I wouldn't need any of that. Okay, I would just simply plug my length, width, and height right into my volume formula and calculate the volume like a normal pyramid. All right, so that's it for this video. Hope you guys enjoyed that. I wish you good luck on the quiz, and we will see you on the next video.